Good afternoon, everyone. So in the previous class, we discussed on the data structures using Java. So some technical problem is there. That's why it's not recording to the voice, and some slides also it's not visible. So again, I will tell you the data structures using Java. So here we have some black one we discussed in the list and the stacks. And that one black one we have to discuss to the unit 1, unit 2, and unit 3 in the today class. So what's meaning of data structure? So data structure is nothing but collection of records or files. Okay, it's we're doing to the set of operations. Then it will be the structure will be coming. Okay, the particular operations, different operations we are using, then structures will be coming. So that is nothing but data structure. So here data means some collection of different records. Okay, records. So here structure means set of operations. What is that? Set of operations. So operations is nothing but like we have to doing some different operations like insert, update, delete. And these are the operations. And stock, we are using the stock operation, push operation, pop operation, and front operation, read operation. So many operations we discussed in the next slides. Okay, so this is the definition of data structure. Data is nothing but a collection of records. It will be stored in the some set of operations. Some structure will be coming. We doing to the some set of operation. Some structure will be coming. So that is nothing but data structures. Here using Java. So when in our different languages is there, C, C++, Java, Python, so many languages there. Here we're implementing to the data structures using the Java only. What is that? Java. So we discussed the stacks and queue. Okay, stack and queue. So this is the some operations we are doing to the some we stored in the some data. We have to fill the data and remove the data. Everything is there in the stack and queue. And some mathematics problems also we have to analyze this. These are the mathematics. So some proof of induction, some powers up to, some binary numbers, some exponents and all logarithms, some using asymmetric analysis. So this everything is doing to some operations. Yes or no? In the mathematics also we are doing to some operation. So for example, binary numbers is there. So this is also 1, 0 is operations or not. We have to calculate the 1, 0, 1 plus 0. So this is the one operation. Okay. What will be result will be coming 1. So this is the operation. So based on these operations, we have to do the some particular things. Okay. So particular formulas. So next slide. So recursion revised. Recursion revised. Here you observe here. So what is recursion? Recursion means, for example, how big problem is there? What is the big problem is there? This is the big problem. It will be solved is very difficult. That's why the recursion is doing this big problem is the subparts. What is that? Subparts. Okay, this is the subparts. Then this problem it will be solved easy, and this problem is solved easy. This problem also solved is like this way. So whenever the big problem or complicated problems is there, that particular problem, it will be converted into the smaller smaller sub problems. Then automatically it will be calculation, it will be easy. And then it is recursively. What is that? Recursively. So that is nothing but recursion. What is that? Recursion. So here the definition also I given. So see the definition. See the definition. So recursion is the way to simplify a complicated problems. What is that? Complicated problems into smaller subproblems, complicated problems into smaller subproblems by calling itself recursively. By calling itself recursively. It is nothing but recursion. What is that? Recursion. So this is the definition of recursion. What I am telling recursion means whenever the complicated problems is there, that will be divided into the sub problems, then that completed sub problems it will be calling to the itself. So that is nothing but recursion. Okay, so that is the recursion. So next topic, templates. In the generic templates is there in the C, C++, Java, everything we have to do the some program writing to the code. What is that? Template means writing to the code, way of writing in the programming code. That is nothing but generic templates in C++. So here definition also giving, templates are the foundation of generic programming, which involves writing code in a way that is independent of an particular type. So this is the writing of a code. Okay, this is nothing but templates. So a template is a blueprint of formulas or creating a generic class or functions. So whenever the predefined classes is there and functions is there in the every programming language. So for example, I want to write some class name. How to write in the class name? Some class name. Okay, we write class name here computer. What is that? Computer. So this is the generic template in the Java. And function also we're giving some add. So this is the some function. So function it will be coming to the open braces and close braces. And subtraction, this is also one of the function. Okay, so different generic templates is there in the every language. So here C++ also we have to do the some class and some what is that functions is there. So these functions it will be used in the some we have to use it in the some programming concepts. So this is the class and functions in the templates. Some examples of us. Mainly, what is generic template in C++ is nothing but it's writing a way of writing a code. So how to write the code? Some predefined commands is there and user defined commands is there. We have to use them, then it will be writing to the code. So that is the generic templates. Next, algorithm. So algorithm is nothing but step-by-step procedure. Is that step-by-step procedure? So this is the algorithm. Algorithm, whenever it will be algorithm is coming, so we have to start method. What is that? Sorry, not method. We're doing the some steps, sequence of steps. This is the start. Then we have to variable declarations, and we have to operations, and we have to do the endpoints. So step by step, this is the other step by step. This is the first step, second step, third step, fourth step. Like this way, it will be step by step procedure will be coming in the algorithm. Once your algorithm is completed, that will be implementing to the any language, not only one language. It will be more than one language. It will be implementing. For example, addition of two numbers is there. Okay, I write the algorithm. Addition of two numbers. Start. We want to addition of two numbers is nothing but I want variables. We have to declare the A, B, C, and here addition A plus B. Then it will be stored in the C. C equals to A plus B like this way. So C will be print. Print C. What is that? Print C. Then here end the algorithm. So this is the step-by-step procedure is there in the algorithm. So in this algorithm, we have to implement it to the code in the any language, either C, either C++, either Python, either Java. So like this way, once your algorithm is done, then automatically the algorithm is implemented in any language. So that is given in the this slide. So see, algorithm is a step-by-step procedure which defines a set of instructions to be executed in a certain order to get the desired output. So algorithm was generally created independent of underlying languages. Okay, we have to create the independent languages also. Okay, An algorithm can be implemented in more than one programming language. Here, important point is more than one programming language. Once your algorithm is done, we create the algorithm that will be implemented in the more than one language. So next, algorithm analysis also is there. So here algorithms of prior analysis is there and posterior analysis is there. So prior means algorithm before implementing the algorithm. What is that? Before implementing the algorithm. That is nothing but prior analysis. And posterior analysis is nothing but after implementing to the program or code. So that is the posterior analysis. So for example, here process speed. We don't know in the implementing the first we developed the CPU. That time we don't know processor speed, but we have to doing the we fix the processor. But when that speed will be calculating posterior analysis, that time we have to evaluate to the some what is the time of the space of the program it will be taking to the processor. That will be calculated to the posterior analysis. So next slide. So this is the first unit. The introduction part will be completed. So here's the second unit, the stack. What is the stack? Here the abstract data types is there, ADT. Abstract data type is there, ADT. So ADT, abstract data types. So in this abstract data type, we have to discuss in the stack and queues and linked list. What is that? Stack and queues and linked list. So we discussed in this one abstract data type. What is meaning of abstract? I give you in the next slide. So here, what is the meaning of stack? What is the meaning of stack? Stack is a linear data structure. Stack is a linear data structure. It is used to store the collection of objects. What we have to store in the collection of objects. It is based on last in first out. What is that? Last in first out. So what is the meaning of last in first out? For example, stack, it will be diagram. Implementing to the stack diagram is like this way. So this is the some different stack operations. So here I want to store the elements in the, for example, A, I'm storing at B, I'm storing at C, and so on, D, and so on. So understood? So here last in, so this is the last one now. This is the last one now. Whenever the give to the input, this is the last in. What is that? Last in. Okay. First out. What is the first element is there in the way deleting to the first out? What is that? First out. So the last in and first out. So this is the stack diagram. Okay, I will show in the next slide also for understanding purpose. I take it. The stack data structure is the two most important operations that are push and pop. What is that? Push operation and pop operation. So push will be we are inserting to the elements. Pop will be we deleting to the element. Inserting and deleting. So this don't confuse them. Push will be inserting to the elements. Pop will be deleting to the objects or elements. Okay, that is the stack. So here a stack is an abstract data type. Already I'm telling now. So abstract data type commonly used in the most programming languages. We are using to the stack. Okay, it is named stack. It has behaves like a real world stack. For example, in the real world, some cards, deck of cards. Okay, so cards. 52 cards is there now. We have to arrange the 52 cards in the one by one. So that is also stack. Yes or no? So in the playing to the cards, some rummy, some different playing to the cards, no. So that is the deck of cards and peel of plates also. We are arranging to the some plates in the one by one. Okay, one by one. This is also stack. Example of the real time stack. So here arranging to the step by step in the stack. So whenever we arranging these two techniques, we are using to the operations. Which operations? Push operation and pop operation. What is that? Push and pop operation. Push means we inserting to the elements. This is the stack. No, we are inserting to the elements. Pop means we deleting to the elements. So this is the stack abstract data type diagram. So this is the stack. Okay, understand? So next we discuss to operations of stack. Here already we discussed. Okay, first push is the one operation and pop is the another operation. I want to tell you the push, how to push into the elements in the stack. So this is the stack. Okay, this is the stack. So in this stack, this is the first time we didn't push any element. That's why it will be empty stack. What is that? Empty stack. Then I push the 20. Then the 20 will be stored in the last element. So this is the first element we have to store in the last 10. What is that? Last 10. Then push 13, I store in the second. Okay. And then I push 89. So that will be stored in the third element. And I push 90. So like this way, I push so many elements in the top of the stack. So here the stack will be full. Okay, my stack will be full. So this is the 18 is the, what is that? Top of the stack. So this is the push operation. Push means first 20 I pushing and 13 I pushing and 89 and 90 and 11 and 45 and 18. So these are the push elements. Push means we pushing to the elements in the stack. Like this way we pushing. Okay, like this way we pushing. Pushing means inserting to the elements. Okay, this is the push operation. Okay. So next we discuss to the pop operation. What is that? Pop operation. So I want to do next slide. So here observe here. Once you push the elements, so I push in the before this one elements, no. So I push the elements. Then after I pop the elements. Pop means deleting. Is nothing but, for example, 18 element is there. I pop 18. So then it will be removing. Yes or no? In the second stack, it will be removing. Then after I push, I pop 45. Then it will be coming in the this only. And then after I pop 11 also, it will be coming. So this is nothing but first out. What is that? First out. Whenever pop operation will be coming, that will be here in the first out. What is that? First out. So last in, first out. So that is the different operation in the stack. Okay. So here first out element in the first out. So whenever these are the way popping, it is also whenever you step by step you have to go to the pop, then what null value will be coming, then it will be stop the pop operation. So that is the push and pop operations. So next applications of arithmetic expressions. So here different types of applications is there in the stack. So we are using the stack. So we have to evaluate the arithmetic expressions and backtracking mechanisms and elementary checking also and reverse a string or data and processing function call. So these are the applications of the stack. We are using the stack, different ways to applications is there. So these are the some evaluation of arithmetic expressions and backtracking and elementary checking, reverse a string or data and processing function calls also we have to do the some applications. So one by one we discuss. So here evaluating the expressions. You know, expression is nothing but mathematical, some arithmetic expressions is there. We have to give the some arithmetic expression. So here you observe here a plus b minus c. This is the some expression. What is that? Some expression. This is the some expression. Sorry, I will take another color. So this is the some expression. What is that? Expression. Okay. So here you observe here this expression a plus b minus c is there. No? Here some operands is there and operations is there. What is that? Operands and operators. So operands here a comma b comma c is the operands. So these are the operands. And what is the operation? So plus is the one operation, minus is the one operation. So here doing a plus of b minus c, we're doing to the some expression. Okay. So in this expression, we have three types of notations is there. What is that? Three type of notations is there. So on that one, infix, prefix, postfix. Okay, these we discussed in the next slide also. Infix, what is the infix, what is the prefix, and what is the postfix. Okay, these are the some evaluation of arithmetic expressions. So next we discussed the backtracking. So whenever backtracking another application of stack is there, it is a recursive algorithm that is used for solving of the optimization problems. So optimization is nothing but the big problems is there. We have to doing to the some particular things. So here some DFS algorithm is there. Okay, this is the some DFS algorithm. We searching to the elements. Okay, we searching to the elements. So we have to do the some depth and then go to the backtrack and then go to the down and then go to the backtrack. Like this way, it will be searching to the elements. So stack also it will be used in the some backtracking mechanism or application. Okay. Then delimiter checking also. The stack will be delimiter checking. Delimiter checking is nothing but parenthesis checking. Okay, what will be parenthesis there in our application? Okay, that will be involves the analysis of the source program, syntactically correct or not. Everything it will be telling in the delimiter checking. Okay, what will be there in the code. So that will be there in the stack also. And reverse a string. What is that? Reverse a string or reverse a data. Suppose what is the reverse? Reverse means once, for example, welcome. Welcome is there now here. This is the welcome is there now. In this welcome, it will be coming to the some reverse. Reversing means what is the reverse a string? How to reverse them? We need to some recorder also. What is that? Recorder. What is that? Recorder. Recorder is the data so that the first and last elements will be exchanged. For example, here I wrote welcome. Is that welcome? Here first element is exchanged here and last element is exchanged here. So here E and W, like this way it will be reverse a string. What is that? Reverse a string. Then after E will be coming here and M will be coming here. So M, E, like this way. And L will be coming here and O will be coming here. So O, L. The remaining one word is there now that will be inserted in the middle. So observe here, welcome, it will be coming in the EMO CLEW. So this is the reverse string. Okay, elements will be reversing to the some of the using to the some stack application. Understood? So processing function. Okay, what is the processing function calls? So whenever we use the functions, so here we use the some recursion mechanisms. For example, ABC is the functions is there ABC. Okay, in the function involves. For example, here we start the program. The cursor will be coming in the main method. In this method, it will be coming in the step-by-step process. Here, a function will be there. So this is nothing but function now. A function is there. Here, add a, it will be coming. So what is the meaning of add a? The function will be calling to the a. So where a is there, it will be a is there in the another another function. So here a again it will be start in the method. Then here step by step process. Here b be calling to the b. Then again it will be calling to the function b. So like this way in the b we will be calling in the c. So c what is there in the application that will be executed. So like this function calls. What is that? Function calls. So this is also some used in the some function calling in the applications in the stack. So here reverse a string that will be there in the how to reversing the string also. So here not only particular things we have to see the string reverse. Okay, what is reverse a string? So here already we stored in the WELEOME. So in the stack operation, then we pop one by one. So E will be pop, then M will be pop, then O will be pop, and C will be pop. Here some mistake is there. So this is EMO. So this is not E, this is C. Okay. So C will be pop, and L will be pop, and E will be pop, and W will be pop. So this is the last output was the pop operation. So whenever this operation we pop into the elements, that will be coming. So this is the reverse C string. Okay. Then again you push them, it will be coming to the push to the E and M and O and C, like this way we pushing to the elements. Automatically the reverse C string will be coming or not. So that is the reverse A string. Once you pop and push, then automatically the reverse A string will be coming. So here infix and postfix and prefix. These are the some three notations there: infix and prefix and postfix. So what is expression? Expression is nothing but some some collection of operands and operations we doing to the expression. So here infix. So infix means all these expressions are in infix notation because the operator comes between the operands. What is that? Comes between the operands. So observe here A plus B and C minus D. Okay, I wrote here A plus B and C minus D. So here the operator, this is the operator, no? And plus also operator, no? So this is the operator and minus also operator. The operators will be coming in the middle in the operands. That is nothing but infix notation. What is that? Infix notation. So this is the infix notation. This is the operand, this is the operand. So it will be, operation will be coming in the middle. So this is the expression. So nothing but this is the infix notation. Here also C is the operand, D is the operand, and minus is the operation. So total is nothing but C minus D is the expression. So it will be middle is coming now. So this is also infix notation. Infix notation. So understood? Got the point? Then go to the next slide. Sorry. Prefix notation. What is that? Prefix notation. Here pre means beginning. Pre means beginning. So in this notation, A is apparent and B is apparent. Okay, the operation will be coming in the pre. So this is nothing but A plus B. So this is the prefix operation. Prefix operation, and minus also is there. So I write them. So this is the operand and this is operand. It will be coming in the free. So this is the prefix operation. So before we discuss to the infix is nothing but two operands A and B. That operation will be coming in the middle. That is the infix. Yes or no? But here the operation is coming in the beginning. That is nothing but prefix operation. That is nothing but prefix operation. Okay, got the point? So next, last one, last slide is the second unit. So postfix notation. You observe post means after. Post means after. So in the A, B, then plus the operator is coming in the last. Operator is coming in the last. This is the postfix notation. Postfix notation, and CD plus. So this is also postfix notation. Like this way we write the operations and the operands in the infix and postfix and prefix expressions. Prefix expressions. Okay, like this way we discuss. So I wrote here some infix and prefix and postfix in the one. I write here. So this is the right. So A, plus B. A plus B, this is the infix operation. What is that? Infix. And prefix nothing but plus AB. You write plus AB. This is the prefix operation. Prefix. And AB plus AB plus. This is the postfix expression. So these are the three types of expressions is there. So this is the infix expression, and this is the prefix expression, and this is the postfix expression. We have three expressions is there in the stack operation. On that stack operation, A plus B, two operands is there, that in the middle operator we are using, that is the infix operation, and two operators is there that will be coming in the pre is nothing but beginning in the operands, that is the operator will be coming, that is the prefix operation, and after operands then operator will be coming the last, it is coming, so that is the postfix operation. Okay, so this is the different types of operators. So next we discussed the third unit. Next, we discussed the third unit. So here, observe them. The least ADT. Here we discussed in the second unit is the stack ADT. Here we discussed in the ADT what is the least ADT. So least means the linked list concepts will be coming. Okay. So abstract data type. Abstract means the hiding the data. Okay. Abstraction means hiding the data. So we know the data types. The signifies the type of the space we created to the space in the data types we are using to the programs. Okay, in the abstract data type is a special data type that is defined by a set of values and a set of operations on that type. Okay, here we stored in the data the set of operations we doing to the set of operations. So what is the meaning of abstract? Abstract is nothing but because these are independent of any implementation. What is that? Any implementation. We can use these data types and perform different operations with them. So we have to do the what is that operations we doing to the abstract data type of different types of operations we doing to the particular things. So here we doing to the some various Java abstract data type. When show the various types of data abstracts here, observe here. So abstract data types of three types mainly: the list ADT and stack ADT and queue ADT. So in the list ADT, we get an insert to some remove. These are the operations, and in the stack ADT, some push, pop, peep in the operation, and queue ADT also some NQ and TQ and peak is the some of the operations. So already we discussed in the push and pop in the stack operations. Okay, then I will go to the list ADT. So here list ADT. So the list abstract data type of list that contains similar elements in sequential order. What is that? Similar elements in it will be arranging to the sequential order. That is the list. Okay, the list ADT is a collection of elements that have linear relationship between each other. A linear relationship means that each element of the list has a unique successor. Okay, so this is the list ADT. So we have to interface between some classes and implementation of the data types. So we are using to the list elements. We are using to the arrays. What is that? Array. Array is the data structure. Initially, we implementing the particular things. Okay. The array list class while the list data structure we have to implement it to the some linked list class. What is that? Linked list class. So what is meaning of so here we used in the some linked list concept. We have some methods we are using So these are some operations, some get operations, some insert operations, some remove and remove at and replace, some size and is empty, is full. These are the we are using to the some operations doing to the some list operation. So here some written an element to the specific index from the list and insert an element at any position and removes the first occurrence in the any remove the element and remove it. So here we so many methods we are using to the some inserting and deleting to the some of the list. So here some array list and vector list is differences also is there. Okay, here vector will be synchronized list and array list is the not synchronized list. Okay, and it will be legacy classes. It is not legacy classes. Here it will be legacy classes. So we have to read them in the differences. So here implementation of a vector. What is that? Vector. Vector class. The vector is also class, one of the class. It will be implements the growable array of objects. Vectors fall in legacy classes. Yes or no? In the already we discussed in the previous diagram, it should be legacy classes. But now it is fully compatible with collections. It found in java.util.package. Which package? java.util.package. So this package is available in the vector class. So in the Java, every class is stored in the some of the packages. So we insert to this particular package, then vector it will be we have to use the vector class. Otherwise, it's not coming. Okay. So that programming concept, I introduced the program concept. Then you have to understand. But here we don't have time now. That's why I explain the concepts. Okay. So in the vector elements also we have to do the some arrays concept. It will be some of the we stored in the some elements. Okay. So next we discuss some constructions. So here vector, we create the default vector of the initial capacity. We create the object. What is that? Vector E. V equals to new vector of E. So this is the predefined object creation. For example, in this object, we have to size also, we give to the size. So that time we have to write the this command. Okay, vector V equals to new vector of int size. We mention to the size also. Then you have to write the some integer increment also. That time you have to create the object in the vector class. Vector V equals to new vector of int size comma into increase. So into increase. So likely increment plus plus or minus plus plus it will be incrementing to the vector size also. So here vector collection class we declaring the object creation. So vector V equals to new vector of collection C. So this is also vector class. Okay. Then the next slide. So performing various operations in the vector class. Here adding to the elements, updating elements, removing and iterating elements. So adding elements. So we are using to the two methods. We are using the two methods, add index and object. So these are the adding to the elements. So this method we are using adding to the elements, and set method we are using to the set the element. So updating the elements, and remove method we are using to the removing to the some of the elements, and get method we are using it will be some iterating to the elements. So these are the some different operations on the vector. Okay, these are the different operations in the vector. Okay, so adding means add method we are using, and updating means set method we are using, remove means remove method we are using, and iterating means get method we are using. Okay, then implementing a linked list. So here we linked list means one for example, one array is there. This is the linear data structure array. This is the linear data structure array. So here this the first element is data. This is the next empty, and it will be stored in the B element, and it will be coming in the C element, and coming in D element. So last will be null. So here it's the starting point is head. So this is the implementing of a linked list. Okay, linked arrays. Linked list is a linear data structure and arrays. So linked list elements are not stored the continuous location. So here the elements are linked using pointers as a below. So here this empty spaces is there, no? These are the pointers. What is that? These are the pointers. So here our linked list concept, we have single linked list and double linked list and circular linked list is there. So here we observe here. So what is the meaning of a single linked list? So here you observe here in the single linked list means you observe the diagram. What is that diagram? So I zoom it. Okay. So you observe here. So here node 1 is there, no? In the node 1 is pointing to the node 2. So this is node 1 and this is address box. This is pointing to the node 2. Okay. And node 2 is pointing to the node 3. Okay. The node 3 is pointing to the node 4. So this is the single way it will be pointing to the starting to ending node. So that is the singly linked list. What is that? Singly linked list. Singly linked list. For example, a definition also you have to see them. So the singly linked list is a linear data structure. So in which is each element of the continuous a pointer which points the next element. Understand? The pointer is points the next element of each list. Okay, that is the definition. So here observing the node 1 is the head. This is the head node of the list, and node 4 is the tail. So this is the last is there, no? This 4 node is the tail. This is the head node and this is the tail node. Okay, each node connected to such a way that 1 is pointing to node 2 and 2 is pointing to node 3 and 3 is pointing to node 4. So this is the example. So this is the head node and this is the head node and this is the tail node. Head node is pointing to the second element and second is pointing to the third element and third is pointing to the fourth element. So fourth node. So for fourth, after that it will be no elements is there. So that is the null element. So that is the fourth node is pointing to the null. Okay. So this is the concept of singly linked list. Then go to the next slide. So doubly linked list. You observe here some diagram. Automatically it will be understood. Doubly linked list. Sorry. So observe here. This is the doubly linked list. So in the before that, this is the head node, no? This is the tail node, no? But here A is pointing 2, 2 is pointing 3, 3 is pointing 4, 4 is pointing 5. Then after there is no ending node, it will be null. Then it will be reverse. Seeing doubly means 5 will be pointing 4, 4 will be pointing 3, 3 will be pointing 2, 2 will be pointing 1. So this is the doubly linked list. Okay, or doubly linked list. And one after it will be null value. Okay, this is the doubly linked list. Whenever we insert into the values, we are using to the some doubly linked list, then it will be some reverse. Okay, once you complete the list, that will be coming in the next. So here already given to the example also node 1 is representing to the what is that? Node 1 is represented to the head of the list. The previous pointer of the head node will always pointing null. So here always pointing null in the previous. Next pointer of the node, it will be pointing to the 2, 2 will be pointing to the 3, 3 will be pointing to the 4, like this way. Up to node 5 is represent the tail of the list, whose previous pointer will be pointing to the node, and then next it will be coming the 3 2 like this way. So this is the doubly linked list. Doubly linked list. So last slide, circular. What is that? Circular linked list. So here, observe here, this is the circular linked list. Okay, circular means circuit. What is that? Circuit. For example, A is pointing to the B is pointing to the C is pointing to the D. Then there is no values in the D. It will be coming in the null. Then that will be coming to the A. Again, the D will be pointing to the A. So this is the circular. What is that? Circular. A circle is forming or not? A will be pointing to the B will be pointing to the C will be pointing to the D will be pointing again A. So this is the circular linked list. So we have three types of list is there. First one is single list. Second one is um, doubly linked list, and third one is circular linked list. So what is the differences with I give the diagram, the three variations of the list. Okay, yeah, understand. So for example, so I wrote here in the diagram. So here singly linked list means, for example, so this is the linked list concept. So yeah, yes, we take 3 boxes. So what is singly linked list means? Single means first it will be pointing to the second element, second is pointing to the third element. So this is the only one direction. That is nothing but singly linked list. Okay, understood? And what is doubly linked list means? For example, so this is the three data where is there. Okay, so whenever you pointing, one is pointing to the 2 and 2 is pointing to the 3 and 3 is pointing, there is no values now, there is no data available here. Then here null will be coming, and 3 is pointing to the 2 is pointing to the 1, like this way. Here null will be coming. Okay, that is the double direction. Double means it will be coming the both directions. So this is the doubly linked list. What is that? Doubly linked list, both directions. Here only single direction. Okay, and circular means it will be circuit. Okay, for example, so here, for example, 1 is pointing to the 2 will be pointing to the 3, then 3 will be pointing again 1. So this is the circular. One circular is form or not? So this is the circular or not? So this is the circular linked list. So these are the different list. Okay, linked list concept. We have single linked list and double linked list and circular linked list. So thanking you very much, all of you. I hope you understand the topic of stock and linked list in this session. Okay, in that next class we discuss to the queue. What is that? Queue operation. Okay, so thank you very much. What? Tell me.
I want your number, sir.
My number?
Yes, sir.
960.
1 minute, sir. Nine six zero
340.
340.
Yeah, I will type the text box you see here. Okay.
Okay, sir.
Yeah, you see, observe here.
Okay, sir.
Okay, it's coming now.
In chat.
In charts, you see here.
Yes, sir. It is here.
Yeah, you know that one.
5764.
Yeah, don't tell you know that one.
Okay.
Understand, class?
Yes, sir. Yes.
Yeah. Thank you very much.
Thank you, sir. Sir, you